will be, and again I am saying common sense. So I am throwing my idea based on common sense, and you need to tell me whether you are convinced with me or not. Say these four variables are leading to one phenomena, and I am giving the name honesty, just for making it simple. Honesty. Don't try to cross check the spelling. So honesty, right? Now, my common sense says, out of this V1, V2, V3, V4, by some mechanism, just for discussion's sake, believe this, consider this, that I can know that how V1 is connected to honesty, how V2 is connected, how V3 is connected, how V4 is connected, and now you know I can use correlation value for this, and I am having some 4 numbers. Again, for making discussion more clearer, say 0.8, 0.7, 0.6, 0.85. Which variable is very strongly connected with honesty? V3 or V4, wherever 0.85 is. My common sense says, when I have to go further, I will drop V1, V2, V4, and I will consider V3 as a representative of honesty, and my data reduction is done. I am repeating again what I wish to do. I will consider the one variable which I feel is very strongly connected with honesty, and not only my feeling, I am having mathematical support also. I am having coefficient of correlation between V1 and honesty, V2 and honesty, V3 and honesty, and whichever is displaying strongest relationship with honesty, I will make that variable representative of honesty, and in my future work, I will consider only that and drop the remaining 3, and that way my data reduction is achieved. Are you convinced with this approach or not?
I never convinced you. I am not convinced with you.
Okay. So one gentleman is not agreeing. What about others? Not. Somebody should show mercy on me. Show your opinion. Your opinion. Convinced? No. No. Convinced. Go as per your natural instinct. No. We will discuss that. But what about this idea? Yes or no? No. Yes. No. No. Yes, madam. Say yes or no. No tax. Speak loudly. Yes or no? Not come. No problem, ma'am. Yes. Can you see the magic of statistics? Half of the audience is saying yes, half of the audience is saying no. Right? And this is statistics. And this makes subject complex, and this makes subjects interesting. Now, as per the literature, this is a very, very well accepted approach. And this method is known as surrogate variable, the variable which is very much dominating, and it is an approved method. Surrogate variable. You select the that variable which is very strongly displaying connection with honesty, and for future work you carry on your work with that variable, and it is accepted. I told you in the beginning, whatever you will do with conviction and you have support evidences, all research scholars, all academicians will accept that. Yes, ma'am? Completely thrown away. Completely. You need to forget from that point onwards, because you have scientifically concluded that for honesty I need only V3. I don't need V1, V2, V4.
We change from time to time also, the variable may not influence now, this time it may be good, next period it may be changed.
Very correct.
What I suggest you that you take all the factors, make it weighted average of it, then which is influencing that I of PV.
I am not debating that this is good or this is good. I am saying that okay, this was one accepted approach, and there can be another approach or there can be another idea. I am only saying that. We have not designed any hypothesis so far. Research means what? You will, that's why I had started. After factor analysis you will do. You need to first know now which four are showing which phenomena. Only after that you will be able to do this.
Sir, you decide only based on the correlation you decide it.
I am leaning on to you. It is my thought. I think so that correlation is a very good indicator.
Let me my example. If the sales of a particular commodity is influenced by price, influenced by advertisement, influenced by sales per segment, that is it. All three are influencing. They are all positively correlated, highly. Then you are taking only one from that. You are neglecting other important variables. There may be 0.79, 0.80, 0.81. 0.81 may not be much different from 0.79. So that you are taking 0.81, you are neglecting 0.80 correlation, 0.79 correlation. Where is the logic in that? What is there is no logic in that.
No, don't say that there is no logic. Logic is this, that V3 is very strongly connected with honesty.
That's what by 0.01 it is just influence that we know. That may not much.
So you want to take V2, V1 also? Nothing wrong.
No, what the way I have understood that, what I thought that before you started, then these all put together you are giving one, because all will be considered that has been represented commonalities is the factor what I thought. But you are taking only one means again it doesn't give.
The first part is covered here. Already in one approach this is addressed. One researcher had taken the average of all four, not neglected anything. So that is one approach and accepted. If you say I am going to neglect 0.6 and 0.7 and will consider only V1 and V3, accepted. We will accept that statement also, and you carry on your work with V1 and V2. Are you able to understand? You got it? Your approach is addressed here in the approach number 1. And now there is a second approach or second solution. Up to here it is clear. Now there is a third approach also. When you will run factor analysis, there will be a term which is called factor score. What it is called? Factor score. And that will tell you that how much V1 is related to honesty. And factor score is nothing but only coefficient of correlation. They call it factor score in the context of factor analysis. But it is nothing but only coefficient of correlation between V1 and honesty. Now you know the factor score. Now see why this world respect mathematicians like Professor Gaurav Moore. You say this is 23, 28, 29, and here say for example 8, 10, 11, and likewise there are some numbers. What if I multiply 0.8 with 0.23, multiply 0.8 with 0.28, multiply 0.8 with 0.29, and similarly I multiply all factor scores with each one, and then at the end I will add row wise, and this is going to be my one single column. Making sense? More appealing? More scientific? So this discussion is about that how you will reduce 4 columns or 4 variables into one. Out of these 3 approach, and there can be one more based on your understanding, based on your judgment, where you will say that 0.6 or 0.05 were so poor. For this mathematical treatment, I will consider only one and this and this. Agreed. Why I had discussed in the beginning that now this third day, all the discussion will be like this, where a new idea can come and new idea can be applied. But there is a caution or there is a request. Before applying these things, you should have good amount of understanding and maturity. Just for the fun sake, don't do it. Because you need to face a panel or you need to face a group of reviewers who will ask so many questions. Right? So your homework has to be very strong and should be based on very strong proofs, literatures like that. Up to here it is clear? Say yes or no?
Yes.
Okay. So this is the way of doing data reduction of variables. How you will verify that this is method 3 which I had shown you, this was method 1, this is method 2. How you will verify or cross verify that all these 3 data reduction techniques are good, or out of these 3 1 is good or 2 are not good. How you will verify that? And I will not proceed further until unless you will give your answer from common sense.
We can try all and see which gives the more dependable answer or most obvious answer.
The framework, conceptual framework is very perfect. Now further crystallize it and make it doable. I'll give one example where this concept can be applied.
For example, if we have, suppose, productivity as an example, only these.
Let us be here.
Right. So honesty, I'm just replacing honesty with productivity.
Okay. So now honesty is replaced by word productivity. For discussion's sake.
Yeah, for discussion's sake. So there are many things which go into productivity.
Right.
And as you have given many answers, so there can be like what kind of machinery is used, how many people are there in that factory, and how many hours are spent in that production, and what is the efficiency of the machinery. All of these things, they can be V1, V2, V3, V4, V20. All of these things will be there, and we can club all this, and one can be productivity, the other can be something else. So those are different factors of what makes actually a good company or a company's highest whatever production or something like that. So there are many factors which go into why Tata's is the number 1 company, for example. So that is like the higher this thing. Now when we come to one thing called, okay, they have a good productivity. Now within productivity there are 3-4 things. Productivity meaning of the people, of the machinery, productivity. So if we take only these 2 things and say this is productivity, then we take V1 and V2, which is productivity of the machinery and productivity of the human resources, and we say this is productivity. Now when we are taking correlation coefficient, we see that the productivity of the machinery is more contributing to F1, which is productivity, than the human resource productivity, just by correlation coefficient that you are seeing. So one method is average the both out and take productivity. That is method number 1. So average machinery productivity and human productivity, and say this is the productivity of, suppose, whatever, company X. The second method which you said was, because the technical productivity is higher, don't take human productivity, only take the machinery productivity and use it as a proxy for, or rather use it as in sync with productivity their due weightage or whatever we are doing in the third method.
So that is more appealing.
For me, that would be more appealing from a research point of view. But as you have said that there are enough examples or there is enough proof that the other two methods also are
Coexisting.
and appropriate to take on productivity. Is that a good
Very correct.
example?
We should give a big round of applause. Very wonderful explanation. Again, I am repeating the question and take clue whatever Madam had said. Now, you want to test whether all these three are good or not good. One way of looking at it. Another way, which one is good or which one is not good. Same thing in other words. You need to test it. How you will do that testing? Because finally, on the day one, first session which Professor Gaurav had taken, you were explained about scales, nominal, ordinal, and so many things. Now take a clue from that knowledge. Honesty is measured on a typical scale, like this. Honesty is measured on a different scale, like this. Now honesty is measured on a different scale, like this. Now I am putting the same question in statistical terms. You need to verify the scale. When we say, and deliberately I don't use the technical jargon at the first instance, otherwise it looks complex. Simply, you need to verify whether these three scales, or in simpler terms, the way you have quantified them, is good or not good. How you will do that? So, and the answer is in one particular discussion which we had in the last 2 days. The example which is given to you and the example which we are now going to run within 5 minutes, in that there is a data, and that data is having so many variables, and there is one particular variable which is related to one region and another region. There are two regions, say American, South American, North American. Meaning thereby, your data file is having one variable where half of the data is North American and rest is South American. You are having some 18, 19, 26 variables. Out of that, one is this. Now take a clue, place something between this and these three, and recall whatever we have discussed in the last 2 days. Can we do something interesting, innovative, appealing, correct, so that we can prove that these three scales are good or not good? And what method is being adopted by Hare, Babin, Tatham, Anderson and Black? This is a very famous book. Note down the name of the book, Multivariate Analysis by Black, and this Black is same, Ken Black, Business Statistics Ken Black. Black, Babin, Tatham, Anderson, and one more. There are 5 authors. Hare, H-A-I-R, Hare. Refer this book, and I humbly request that you all should buy this book. Because if you have decided that you are going to invest your considerable time in research, author's name? It's Black, there are 5 authors. All are great statisticians. Black, Babin, Tatham, Anderson, Hare. Right? Pearson is the publisher. And there is another book which we have recommended yesterday. What was that book? Business Statistics by Naval Bajpayee. It is a Indian version of Ken Black, where examples are Indian examples. And what was the beauty of that book? Business Statistics by Naval Bajpayee. each example is explained by Excel, Minitab and SPSS. So in one book you will get all these 3 applications. So that's why this book is very special. We recommend this book for our business analytics students, right? And on the day of orientation, I tell my students of business analytics MBA students that these 2 books should be near their pillow always, and whenever they go for whether for vacation or outing, these 2 books should always be in their briefcase, and same applies to you. If you follow that, it will give you great dividend. You need to refer whatever we are going to discuss today from these 2 books, and whenever you have any doubt, these 2, I am having 3 copies of these 2 books, one in office, one in car and one at home. So you can take a picture from page number 232 and say that you have discussed about factor analysis like this. I have studied from this book, and on page number 234 this second para is not clear to me. You take a picture, WhatsApp me or mail me, I will reply you within 24 hours, right? And this should happen. This I tell in each every FDP, rarely 2% people respond, right? And this opportunity or this freedom was not given to me when I was in the learning stage, and when I was learning these things for the first time. There was very little guidance available. So utilize this facility. Whenever you have any doubt, take a picture of these page numbers. Gaurav is also having 3 copies. Gaurav is having 4th copy also at Calcutta home, because Gaurav is from Kolkata. So he is having 4 copies. So even if we are traveling, we are having this book with us. So whenever you will send any query, we will refer the book, page number, make our notes and then give reply. Okay. Or the session is difficult. Session is okay. Now you in this book, multivariate analysis, chapter number 3, factor analysis, what these 5 authors are recommending, that how you should test these 3 scales. You should apply independent sample t-test with the help of these 3 methods on region. Yesterday we had seen the example of independent sample t-test. Mean fresher salary of Kolkata, mean fresher salary of Mumbai. And if you want to compare this, then this is a case of independent sample t-test. Same way, you will apply independent sample t-test on these 2 regions. You are saying that the mean population of North America and the mean population of South America is same on this scale. And if all the results with this are same, then you can say that all these 3 scales are working properly. Or if all these 3 scales are not in sync, then you need to rethink about quantification methodology. Up to here it is clear? Say yes or no.
Yes.
So I have given you a brief understanding of what we are going to do. Now you need to open a SPSS file, which is demo file. So this sheet is with you in the folder. This sheet is also with you. With the name of this document is exercise underscore factor analysis underscore P. Open this document where on page number 1 commands are mentioned which you are going to run. Are you able to see this document in your laptop? Say yes or no.
Yes.
Okay. Now you need to refer these commands. And you need to put all 13 variables from x6 to x18 you need to put all these x6 to x18 variables in your factor analysis procedure, and the procedure is mentioned here. You go to analyze, data reduction, factor analysis. You go to analyze, the file name is hbat factor analysis underscore demo. Open this SPSS file. Vinay, you are having this file? Vinay? Haan. Mahesh? Opening this file. Jyoti? Look at the screen. It is analyze, go to dimension reduction, go to factor analysis, and then rest you follow the commands which I have mentioned on what document. You are required to put all x6 to x16 variables in that top box. Are you able to do? Madam? Okay. Madam, you are able to do? Doing? Day 3 material. What happened to Jyoti? Oh, remove everything. Okay. So day 3 material is not given to you. So open day 3 material. So this is the PPT you open, and this is the file you should open. You are not having SPSS here. Gaurav, she need to have, you have SPSS. So you do one, both should share, otherwise it will take time. But in lunch time, Gaurav, you help her to have.
Yeah, it will have tea.
By the time both of you should work on this. Thank you, Gaurav, you are here. So you are required to run all the commands and then have output, and then I will discuss that output. Yeah, exactly correct.